Now we're at the stage that we have the ELDYN and the DCS connected. We can start looking at the software. I'll just pull up a chair. Now I'm ready to connect the ELDCS unit to the computer. I'm going to first switch it on and then connect the USB to my laptop. Assuming I've already pre-installed the correct INI file, of course I need to have installed the HASP dongle files as well, so that I have permissions to actually run a test. I can start GDS Lab and create a station. Here I'm going to use the INI file ELDYN.ini, which is suitable for this system. The first thing I'm going to do is go to the object/hardware display, and I'm going to click on the icon for the ELDCS unit. We can see the ELDCS unit control panel, and there are no ELDCSs present. So I can click on Select ELDCS, and I can select any available ELDCSs that are on the system. So I choose this one. I choose it by checking the serial number of the unit and comparing it with the serial number that we have in the available USB devices, and I click Select. We should have, beneath the serial number, the status GDS ELDCS connected. Now, in this example, we can see that the system messages below are showing that the drive's not ready. That's because I have not turned on the main load frame. So I'll switch that on now. And now if I look back at the ELDCS control panel, we can see that the system messages have stopped coming thick and fast. I can clear these now, and we have a stable system, no system messages, and we are connected to the ELDCS unit. That finalises the System tab, where system messages that will appear are essentially safety messages or information messages. For example, if I lean forwards here and press the stop button, we will see the system message appears saying that the emergency stop button is pressed. If I now release the emergency stop button, the system messages will stop appearing, and I can clear the system messages window. Moving on to the Control tab, we have two procedures we can follow here. One is called Set Platin Position. The other one is called Move Platin. The Set Platin Position allows us to set the actuator RAM to a particular height relative to its full stroke. So as an example, if I set 50, it will move to the center of its stroke. The full stroke of this system is 100 millimeters, so it will move to 50 millimeters. But the nominal stroke is 100 millimeters, so first it needs to detect and calculate exactly what the full stroke is. So if I say set position, what it will attempt to do is go to the very top of its stroke, and then it will track down to the very bottom of its stroke. It can calculate the full stroke compared to its limits, and then move to a position 50% between those limits. It's good practice to know exactly where the RAM is in its stroke, and I thoroughly recommend we set the RAM to 50% of its full stroke before we proceed. Note, you must always have the triaxial cell out of the load frame, as we have here, for risk of crushing whatever you have in the way of the RAM. The Move Platin section in the control panel simply allows us to move up. If I press move up, the actuator will move up. If I press move down, it will move down. If I press stop, it will stop. Simply a convenient method of moving the actuator when we are loading the cell into place, whatever we might want to do with the actuator. If we now move to the DIO status tab, we can see the current digital I/O status of the control system. This tells us important information for diagnosing the system should we have any problems. As an example, if the emergency stop button is pressed, we can see that the block next to emergency stop changes from green to red. If I unclick the emergency stop button, it changes immediately back to green. So it gives us a great idea of exactly what's going on in the system. As another example, if I turn the ELDYN load frame off, we will see that the drive ready and the drive enabled DIO bits will turn to red. Now if I turn the ELDYN machine back on again, we will see that the drive ready status immediately turns to green, but drive enabled stays red. Now this is interesting because we haven't sent it any control signals yet. It keeps the drive disabled. But if I just run to the control tab, move up, stop, back to the DIO status, we can see that the drive enabled itself as soon as it was requested to make a movement. The final tab is called RT graphs. This stands for real-time graphs. You will see in a moment that when we run the test, we have a window of real-time graphs, which enables us to see exactly what's going on in the specimen during the test. We can select which channels of the DCS we want to see in the two real-time graphs that are displayed. It's common to show channel 0, which is the load cell, and the encoder channel as the second graph, which is of course the displacement. It is possible to display channel 1, 2 and 3 if you want to see dynamically in real time the pore pressure build-up, for example. It's also possible to turn the real-time graph off.